All right, so a lot of you guys are fresh out of Algebra 1. So this is going to be one that you remember and something you're probably very good at. So this is going to be section 3.3, and we're going to talk specifically about slopes of lines. Okay, so just a little refresher. Slope is a number that describes the steepness of a line. So is a number that describes the steepness of a line. All right, we're going to write down some different ways you've seen slope. So first of all, you see the word slope, right? Well, that's equal to the letter m in your y equals mx plus b. Okay, that's also equal to negative a over b when you're in your ax plus by form. That's also equal to y2 minus y1 over x2 minus x1, which is your slope formula when you're given coordinates. Well, that's also equal to delta y over delta x. Okay, delta is a Greek letter that's used to represent change between two things. So the change in the y values and the change in the x values. So that's what these little triangles mean. Okay, slope is also rise over run. That's when you just count the spaces on the graph. And you may also see something say change in y, change in x, and you may also see rate of change. Okay, so all of these things, you've seen all of them before, or you've seen most of them, they all mean the same thing. So we're going to go back to the one that you're probably going to use the most, and that's the slope formula. This is one you want to know, right? This is going to come up over and over in math. And the slope formula says that m equals y2 minus y1 over x2 minus x1. And we're going to draw a little picture of just what that means, because I think some people know the formula, but they don't really know what it means. So we're going to draw a small little xy plane. It doesn't have to be anything special. And we're going to put a line going across our xy plane. So there's our line. We're going to talk about this x2, x1, y2, y1. So on this line, there's going to be a point. And that point corresponds to some value on the x-axis. And since this is our first point, that value is going to be x1. It also corresponds to some value on our y-axis. And so that is our y1. If we move farther up the line, we're going to find more points. And at this point, this is our second point, that has an x value that we're going to call x2, and it has a y value that we would call y2. So if you were labeling these points, you would label this point as x2, y2, and you would label this point as x1, y1. So hopefully that all looks familiar and it gives you an idea of where the x2s and x1s and all that comes from. But you want to start to try to understand pictures like this. All right, we're going to write down 4 things that you should know perfectly. The first one is positive slope. We're going to write all 4 of them across here. So positive slope, there is negative slope, there is zero slope, and there is going to be an undefined slope. All right, and we are going to draw a quick, very unartistic picture of each one of these. So positive slope looks like that. Negative slope looks like that. Zero slope, this is where people get mixed up, looks like that, horizontal line. And undefined slope looks like this, a vertical line. And we're going to write down a little bit about each one of these, very little bit. So positive slope means that our positive delta y over delta x. That means our slope in our equations is a positive number. Negative slope means we have a negative delta y over delta x. Zero slope means that our slope is zero change in the y's divided by whatever the change in the x's may be. And our undefined slope means that we do have changes in the y values, but the x value remains the same. And the reason it's undefined is because you can't divide by zero, right? So that's our undefined slope. Right, we're going to write down two theorems and we are going to be done. First one is the parallel lines theorem. Right, the parallel lines theorem says that two lines are parallel if and only if they have the same slope. Okay, remember, if and only if is used in a biconditional statement, which means the statement's true regardless of which way you read it. So two lines are parallel if and only if they have the same slope, and we could say two lines have the same slope if and only if they're parallel. So this is basically a definition of parallel lines. So we're going to write down y equals 2x plus 3 and y equals 2x minus 7. And real quickly, we can see that they have the same slope, right? It's the same exact number. So these two lines are parallel. Okay, I just want to have a little example for you to look at. Our next one is called the perpendicular lines theorem. So perpendicular lines theorem. And these are super important. Not so much the words, but just the fact that you can recognize parallel and perpendicular lines when you look at the equations. That'll carry you well through calculus and into much higher math than I can do if you can understand this and recognize them when you see them. So, two lines are perpendicular if and only if their slopes are opposite reciprocals. Okay, opposite reciprocals are like this. Okay, there are two numbers that when you multiply them together, they equal -1. So these are opposite reciprocals. So let's bubble that just so you know what opposite reciprocals are. Now you're not ever actually going to do this because this is way too simple to waste time actually doing math on. So we're just going to write down the examples and you'll see it very easily. So we're going to have y equals 2/3 x minus 1 and y equals -3/2 x plus 5. Okay, when I look at these immediately, I see their slopes. What you're looking for in the slopes is the 2/3 is flipped over and the sign is changed, so those two are perpendicular. Okay, perpendicular is when the slope is flipped over and the sign is changed. So if it was negative, it's positive. If it was positive, it's negative. The numbers switch places. Another example, just a real quick one, is if you see this, y equals 2x minus 4 and y equals negative 1/2 x plus 3. Okay, 2x, it's really 2 over 1, right? So that is perpendicular to negative 1 over 2. So typically, this is the only kind you'll really get caught on. You'll make a mistake on, because you'll forget that 2 is really 2 over 1. So that's it. Parallel, perpendicular, easy stuff. See you tomorrow.